We saw how we could run a script file containing a sequence of 3 commands that though these are commands that we could normally just type in at the command prompt using the keyboard, but instead of doing that we can put these commands into a file and they will get executed sequentially, that is one by one. And we saw also that the preferred way of setting up scripts will be this last way, that is by having the first line of the script tell the operating system that this file should be interpreted by /bin/bash. This is just telling the system that this is the interpreter that's going to execute these commands. And that's what you want to do for the rest of this semester. All your scripts should look like this. Let's take a look at some of the details of the statements that we used. We used echo, which is like a print statement, and this is what we use to display output. So the echo command is used to display output on the screen. That's standard out, and any ASCII character can be displayed, including special ones like backspace, and you have to use the -e, for example, for some of these special characters and put things into for example, double quotes. You can use \b for backspace. You can backspace. You can inhibit the default next line at the end of the string. Sometimes that's handy for asking the user questions. You print something and don't go on to the next line. You just have the user enter something right after your program prints something. You can force a new line to be drawn. You can force a carriage return without a line feed. This is useful when you want to print out updates, for example, and not have new lines for each update. So there are situations where you want to use carriage return rather than the carriage return and line feed. You can use tabs. You can print out ASCII characters that are represented in octal if you use the / and 0 in any number. This number will be represented in octal. Okay, and we also saw that the very first line I said was a comment, but then it was also a sort of like an indication to the operating system that this file should be interpreted by this interpreter. So anything that starts with a # is a comment. So this is a comment. This is also technically the very first line. That is also a comment, but it's a very special comment in that it tells the system, okay, don't execute this line, but this is it's telling the operating system that this is the interpreter that will run the actual lines of code that are not comments. Okay, so the # indicates a comment. Anything to the right of it is ignored by the bash interpreter. So once the bash interpreter is loaded with this, you start up the bash interpreter. It does not interpret this line nor this line because it's considered a comment, and then it goes off and does this line. And if you have a comment on a line containing a command, everything after that to the right of it is ignored by the bash interpreter. Okay, so how do you do stuff in shell scripts? You need variables, just like you need variables in high-level languages like Java and C. Shell variables are named memory locations. So you use them just the way you give a value to a variable is just to say variable name, no space, and then the equal operator or assignment operator, and then whatever you want to put into that variable. If you have some number of spaces and then a #, the rest of that is just a comment, so it's ignored. That does not go into this variable. And you have to be careful. I think if you skip the space over here, you might end up putting all of this, or at least some of it, into the variable. So be careful with comments on the same line. You need some spaces, one or more spaces. Okay, So once you define once you set the contents of a variable, how would you use it? Well, here's an example. You can print it out saying by using the echo command, and you have to use the $sign. So this is one thing that's different about a lot of interpreted languages as opposed to things like C or Java. Variable names, they are treated the same whether you're assigning values or you are getting what's stored in them in C and Java. However, in shell scripts, you have to have this $ symbol before the name of the variable. Okay, so for shell scripts, things are a little different from Java and C. When you want to, for example, print out the value of R1, you have to use echo space $sign R1 with no spaces over here. All right, I hope that's clear. So it's unlike C and Java. Another thing that's different with the shell scripts and a lot of interpreted languages is that you do not need type information. So these are not strongly typed languages. Unlike C and Java, which are strongly typed and where every variable has to have a type declared, in the case of shell scripts, you do not need that. So here you're setting the value of x to 5, and here you print it out. So all this will do is set value of x to 5, nothing gets printed by this, and then this line of code, that is the echo command, prints out 5. Then right after that, you can change whatever value is in x, and you can do that in C and Java too. You can assign x equal to 5, and you can assign x equal to 6, 7, 8, any integer. That's assuming that you declared it as an integer. Here, however, notice we did not declare the type, and you don't have to. And if you don't, you can assign a string to x. So we assigned an integer to x. Actually, what you're really doing is just assigning a string to x, and you can interpret it as an integer later on. And here you're because of the fact that you're using double quotes, you're saying, okay, store the string hello there with a space into x, and now if you print out x, you'll get hello there. So at first glance, this doesn't look right because you're storing ints. It looks like you're storing ints and then you're storing strings into the same variable. Yes, you can do that with a lot of interpreted languages like the Bash scripting language. Names are case sensitive and can have letters, numbers, and the underscore character. When you reference a variable's value, use the $ symbol. So if you want to use x, if you want to read what's in there, you have to say $x. Okay, so it turns out, although I said you do not have to declare the type of a variable, you can if you really want to. Well, how do you do that? You use the declare statement. So shell variables attributes can be set using the declare or typeset command. Some of the options are -a for array, and for arrays it's always advisable that you do this, that you say declare -a and then the name of the array. You can declare things to be a function, it's like a method, or you can say it's an integer. You can also say if something is read-only so that you prevent it from writing to it once you set it. And then you can say -x, that is you export it to any scripts that you might call from inside your script. Yeah, so you can do that. You can call one script from another. All in good time. Okay, so let's take a look at the basics first. So you can, for example, say that this is a read-only integer. So after you set the value of zip to 54023, you cannot change zip. Okay, so you can do things like that. This is helpful when if you want to avoid bugs. It's always helpful to make things constant. So that's really what you're doing, is you're saying that zip is now read-only, that is, it's a constant. All right, so you don't have to do this. You can, and it's very helpful. It helps you avoid bugs. So once again, when you assign values It works just like in high-level languages. You use the assignment operator. However, there are no spaces. If you put in a space, everything gets messed up. So you can try this. Set up a script like this, put in a space, x space equals space 5, or you will see that this will cause a lot of problems. So no spaces, x equal 5. Without any spaces, that works. If you want to bump up the value, here's what you do. You say x equals, and on the right hand side you have to have x preceded by a dollar symbol. So that's what says, okay, read the value that's currently in x, which is 5, add 1 to it, 6, store that into the variable x. So you do not want to use dollar symbols on the left hand side of an assignment. You do have to use it on the right hand side. Anytime you read the value of some variable, you have to use the dollar sign. Names are case sensitive and can have letters, numbers. You saw that before. Okay. There are some built-in script variables. So $0 is the name of the script itself. This is sort of similar to C programs. We'll see this later in C programs. You can have any number of parameter, that is command line arguments for your script, but only the first 9 are named. And it turns out if you want to have more than 10 command line arguments for your script, you can do that, but you have to shift everything over so that you make the 10th one the 9th one, and so on, the second one the first one, and then you can read the 10th one, then you can shift again, shift any number of times, but there's only 9 of them that have names. Okay. There are some other there are some other predefined or built-in variables, like $number tells you the number of command line parameters, or the number of arguments that you supplied with your script. So when you run your script like scr1, you can type in file name 2, file name 3, and so on, any number. Okay. So you can also get all the parameters as separate strings using the $@. You can get all the parameters as one string using the $*. And then you also have this built-in variable called $, which is the exit status. The exit status should be 0 unless something goes wrong, and then you set it equal to something else. You can always get the process ID. This is something that we looked at before. Every time you run a program, it has a process ID, and you can get the process ID of the current process using $. Okay, so next up we will look at the set command, a whole bunch of other things that have to do with writing scripts.